The air crackles with an almost palpable energy, a hum that vibrates through the very ground beneath your feet. It's the pulse of a hidden world, a realm of relentless motion and transformation, where the ordinary becomes extraordinary. We stand at the threshold of an industrial marvel, a place where the sheer scale of human ingenuity meets the raw bounty of nature. Imagine a single ingredient, humble in its origin, yet capable of feeding millions, driving economies, and shaping culinary traditions across continents. This is not just a factory, it's a living, breathing ecosystem of production, a testament to precision and power. For most, the journey of a product begins and ends on a supermarket shelf, a neat package concealing a universe of complexity. But what if we told you that behind every bag of flour, every packet of starch, every processed food item, lies an epic saga of logistics, engineering, and sheer human will? What if we could pull back the curtain, not just to reveal a process, but to uncover the very heartbeat of an industry that touches nearly every aspect of our daily lives? This is an invitation to step beyond the familiar, to venture into the colossal machinery that orchestrates the transformation of raw agricultural wealth into the staples we depend on. Today, we delve into the colossal world of cassava, a root crop often overlooked, yet fundamental to global food security. We are about to witness how a single facility grapples with an astonishing challenge, processing 50 million cassava tubers every single day. 50 million. It's a number that defies easy comprehension, a logistical puzzle of monumental proportions. How do they manage such an immense influx? What hidden systems are at play? Prepare to embark on a cinematic journey into the heart of this industrial mystery, to uncover the ingenious methods, the relentless pace, and the meticulous precision required to harness the power of this remarkable tuber. This is the untold story of how the hidden world behind everyday products truly operates. The cassava tuber, often dismissed as a simple root, holds a fascinating history stretching back thousands of years. Originating in South America, it was cultivated by indigenous peoples long before European contact, becoming a cornerstone of their diet due to its resilience and high carbohydrate content. Its journey across oceans, first to Africa and then to Asia, is a testament to its adaptability, thriving in diverse climates where other staple crops might fail. This global spread wasn't just a matter of convenience, it was a revolution in food security for countless communities, providing a reliable source of energy even in challenging conditions. But beyond its historical significance, cassava harbors some truly astonishing secrets. Did you know that some varieties of cassava contain cyanogenic glycosides, compounds that can release cyanide if not properly processed? This inherent toxicity, far from being a deterrent, spurred ancient civilizations to develop sophisticated detoxification methods, turning a potentially dangerous food into a safe and nutritious staple. These traditional techniques, involving peeling, grating, soaking, fermenting, and drying, are echoes of the complex industrial processes we see today, albeit on a vastly different scale. It's a remarkable example of human ingenuity transforming a challenge into an opportunity. Modern cassava processing, while rooted in these ancient principles, has evolved into a high-tech marvel. Consider the sheer volume, 50 million tubers daily. This isn't just about moving roots, it's about managing an immense biological payload, each tuber a unique entity with varying sizes, shapes, and moisture levels. The engineering challenges are immense, from designing machinery that can efficiently peel and grate without excessive waste, to developing drying systems that preserve quality and prevent spoilage on an industrial scale. The precision required to maintain consistent product quality across such a massive throughput is truly mind-blowing. One of the most captivating aspects of cassava is its versatility. It's not just about flour or starch for cooking. Cassava derivatives are found in an incredible array of products, from textiles and paper to pharmaceuticals and biofuels. Its starch, known as tapioca, is a natural thickener and binder, prized for its neutral flavor and smooth texture. This adaptability makes it an invaluable industrial raw material, driving demand and innovation across multiple sectors. The humble tuber, therefore, isn't just feeding people, it's fueling industries and creating new possibilities. The journey from field to factory is fraught with challenges. Cassava tubers have a relatively short shelf life once harvested, often deteriorating within days. This necessitates incredibly efficient logistics, with farmers often delivering their harvest within hours of digging. Imagine the coordination required to manage thousands of smallholder farmers, ensuring timely delivery to avoid spoilage and maintain a continuous supply chain for a factory operating 24/7. It's a delicate dance between agricultural cycles and industrial demand, a logistical ballet performed daily. Innovations in cassava cultivation are also transforming the industry. Scientists are developing new, disease-resistant varieties that yield more tubers per plant and have improved nutritional profiles. These advancements are crucial for meeting the ever-growing global demand and ensuring food security in regions heavily reliant on cassava. The future of this crop isn't just about processing. It's about sustainable farming practices and genetic improvements that enhance its resilience and productivity. Think about the water usage in such an operation. Washing, peeling, and processing 50 million tubers requires vast quantities of water. Modern factories are investing heavily in water recycling and purification systems, transforming what could be an environmental burden into a sustainable practice. This commitment to efficiency extends to energy consumption as well, with many facilities exploring biomass energy generation using cassava waste products, creating a circular economy within the factory walls. It's a testament to how industrial scale can drive environmental innovation. The global relevance of cassava cannot be overstated. It is a primary food source for over 800 million people worldwide, particularly in sub-Saharan Africa, Asia, and Latin America. Its role in alleviating hunger and providing economic stability for millions of farmers makes it a crop of immense geopolitical importance. The efficient processing of cassava, therefore, isn't just a commercial endeavor, it's a humanitarian one, directly impacting the livelihoods and well-being of vast populations. Consider the sheer mechanical force involved in processing. Giant industrial graders can reduce entire tubers to a fine pulp in seconds, while massive centrifuges separate starch from fibrous material with incredible speed and precision. These machines are engineered to withstand continuous, heavy-duty operation, a testament to robust design and advanced material science. The roar of these machines, the rhythmic thud of tubers, and the constant flow of material create a symphony of industrial power, a testament to human mastery over raw materials. The transformation of cassava into various products also involves intricate biochemical processes. Fermentation, for instance, is not just a traditional method for detoxification. It's also used to develop specific flavors and textures in products like gari or fufu. In industrial settings, these fermentations are carefully controlled, using specific microbial cultures to ensure consistent quality and safety. It's a blend of ancient wisdom and modern microbiology, working in harmony to unlock the full potential of the tuber. Even the waste products from cassava processing are valuable. The fibrous residue, known as bagasse, can be used as animal feed, compost, or even as a biomass fuel source, reducing the factory's environmental footprint and creating additional revenue streams. This holistic approach to resource utilization is a hallmark of modern, efficient industrial operations, demonstrating that nothing goes to waste in the pursuit of maximum value. The journey of cassava from a humble root to a global commodity is a story of resilience, innovation, and immense industrial scale. It's a reminder that the products we consume daily often have a hidden life, a complex narrative of transformation that is as fascinating as it is vital. The next time you encounter a product made from tapioca or cassava, you'll know a little more about the incredible journey it undertook and the colossal effort behind its creation. So, where do these 50 million tubers begin their journey inside the factory? It all starts at the receiving docks, a bustling hub of activity where trucks, sometimes hundreds a day, offload their precious cargo. Each truck is weighed upon arrival, and samples are taken from the tubers to assess quality, starch content, and ensure they meet strict specifications. This initial quality control is paramount. Any deviation can impact the entire production line. The sheer volume dictates a rapid offloading process, often utilizing automated conveyor systems that gently, yet swiftly, move the tubers from truck beds into massive holding bins. These bins are designed to minimize damage and ensure a continuous flow, acting as a buffer between the erratic rhythm of farm harvesting and the steady pulse of the factory. From the holding bins, the tubers embark on their first major transformation, cleaning. They are fed into colossal rotary washers, essentially giant rotating drums filled with water, where powerful jets spray away soil, stones, and other debris. This isn't just a superficial rinse, it's a vigorous scrubbing designed to remove every speck of impurity. The dirty water is then channeled to a sophisticated filtration and treatment plant, often recycled to minimize environmental impact. Cleanliness at this stage is critical, as residual soil can abrade machinery and contaminate the final product. Next comes the peeling stage, a surprisingly complex operation given the irregular shapes and sizes of cassava tubers. Traditional manual peeling would be impossible at this scale. Instead, factories employ various automated peeling technologies. Some use abrasive peelers, which gently rub the skin off using rotating surfaces. Others utilize steam peelers, where tubers are briefly exposed to high-pressure steam, causing the skin to loosen and making it easy to remove with brushes or rollers. The goal is maximum skin removal with minimal loss of the valuable starchy flesh. The peeled tubers, now gleaming white, are then inspected, often by a combination of optical sorters and human operators, to catch any remaining imperfections or unpeeled sections. Once peeled and inspected, the tubers are ready for grating. This is where the solid root is transformed into a pulp. High-speed industrial graters, equipped with razor-sharp blades, shred the cassava into a fine, wet mash. The efficiency of this step is crucial, as a finer mash allows for better extraction of starch in subsequent stages. The graters are robust machines, designed for continuous operation and easy maintenance, capable of processing tons of cassava per hour. The resulting pulp, a milky white slurry, is then pumped to the next section of the factory. The heart of cassava processing lies in starch extraction. The pulp is mixed with water and then fed into a series of centrifuges or hydrocyclones. These machines use centrifugal force to separate the heavier starch granules from the lighter fibrous material, bagasse, and water. It's a multi-stage washing and separation process, repeated several times to achieve maximum starch purity. Each stage refines the starch slurry further, removing more impurities and increasing the concentration of pure starch. The bagasse, as mentioned earlier, is collected for other uses, embodying the factory's commitment to resource efficiency. The purified starch slurry, now a thick, milky liquid, still contains a high percentage of water. To produce dry starch, this water must be removed. This is typically done in two main steps: dewatering and drying. First, the slurry passes through vacuum filters or decanter centrifuges, which remove a significant portion of the water, resulting in a wet starch cake. This cake, still containing about 40 to 50% moisture, is then conveyed to industrial dryers. Flash dryers, spray dryers, or rotary dryers are commonly used, employing hot air to rapidly evaporate the remaining moisture until the starch reaches the desired low moisture content, typically below 13%. This precise control of moisture is vital for preventing microbial growth and ensuring a long shelf life. Throughout the entire process, quality control is paramount. Samples are continuously taken at every stage, from raw tubers to peeled roots, from starch slurry to dried product. Laboratories within the factory conduct rigorous tests for starch content, moisture levels, pH, microbial contamination, and purity. Advanced sensors and automated monitoring systems constantly track parameters like temperature, flow rates, and pressure, ensuring that the process remains within optimal operating ranges. Any deviation triggers immediate alerts, allowing operators to make adjustments and maintain consistent product quality. Safety protocols are also integrated into every step, with automated shutdowns and interlocks protecting both personnel and machinery. Once dried, the pure cassava starch, a fine white powder, is ready for packaging. It's often sieved one last time to ensure uniform particle size and remove any agglomerates. Automated packaging lines fill bags of various sizes, from small consumer packs to large industrial sacks, sealing them efficiently. Robotics are increasingly used for palletizing, stacking bags onto pallets with precision and speed, ready for storage and distribution. The final pallets are then wrapped and moved to the warehouse, awaiting shipment. Logistics plays a critical role even after packaging. The warehouse itself is a marvel of organization, often employing automated guided vehicles, AGVs, or sophisticated racking systems to manage inventory. From here, the finished products are loaded onto trucks or trains, embarking on their final journey to markets around the globe. The entire process, from the moment a tuber arrives to the dispatch of a packaged product, is a symphony of coordinated effort, high-tech machinery, and meticulous attention to detail, all working in concert to handle an astonishing 50 million cassava tubers every single day. And so, our journey through the colossal world of cassava processing concludes, but the story of industrial innovation is far from over. We've peeled back the layers of a truly remarkable operation, witnessing how a humble root is transformed into a global commodity with breathtaking efficiency and scale. From the intricate dance of automated machinery to the meticulous precision of quality control, it's clear that the hidden worlds behind our everyday products are far more complex and fascinating than we often imagine. What was the most surprising detail you discovered about cassava processing today? Was it the sheer volume, the ancient origins, or perhaps the ingenious methods used to handle its natural toxicity? Share your thoughts in the comments below. We love hearing what truly captivates you. If you've been captivated by the intricate processes and the relentless pursuit of efficiency we've explored, then you won't want to miss our next deep dive. We're about to uncover another incredible transformation, taking you from sun-drenched palm trees to your plate, revealing the high-tech secrets of how dates are processed in a modern factory. It's a journey filled with surprising facts and cutting-edge technology. So, make sure you hit that subscribe button to join our community of industrial explorers, and click on the video that just appeared on your screen to continue your adventure into the heart of modern manufacturing. You won't believe what goes into bringing these sweet treats to your table.